Hi, this is Christina Granillo-Lewandowski with Microbiology 205 at Arizona State University. This video is for the Module 2 Lecture Video 2 assignment. Today I'm going to be discussing the differences between cellular respiration and fermentation and the path that glucose takes to its final destination, which would be ATP. So to start with cellular respiration, I did want to mention that in my research I found that glycolysis is used among all three domains of living beings and microbes. And it works with either aerobic or anaerobic processes as well, just different means to an end in that case. And the first step occurs in the cytoplasm. So this first step is where glucose turns into pyruvate. And for some non-respiring organisms, this is really the only chance that they have to get the ATP breakdown, but we'll get into that a bit later. From here, the pyruvate moves to the Embden-Meyerhof-Palmas path. And from there are two ATPs formed. The glucose splits and transforms into G3P. This gets oxidized, and the G3P turns into pyruvate. That pyruvate breaks down into 4 ATP molecules and 2 NADH molecules. Now, with that being said, it begins a bridge reaction, or decarboxylation. What happens there is there are 2 carbon acetyl groups from the reaction, and they're added to 4 carbon molecules as well. Now, when this happens, what comes out of that is an FADH2 molecule and 3 NADH molecules. And those 2 molecules go into the Krebs cycle for further processing. The Krebs is not just for glucose, it can also be used to synthesize other substances like nucleic acids or even proteins. So it's a common misconception that I wanted to address. All of my citations will be down in the description box below, so you can check out where I got my sources. Now, with that being said, most ATP is actually generated in the very last step, which is oxidative phosphorylation. For aerobic respiration, the final electron transfer, what happens is the current is in the cell membrane for the electron transfer, and they go from the point of low redox potential to high redox potential. So it keeps hopping along this membrane, doing all sorts of different transfers until it reaches the point where it finds the last highest redox potential area that it can in the transfer chain. And from here, it goes to oxygen, and then that gets broken down into H2O. So water is also a product of cellular respiration. Now moving on to fermentation, there are big differences here. The main one being fermentation does not use an electron transport system, and I was shocked to learn this as well. It only gets the initial ATP from glycolysis and phosphorylation. So, with that being said, the most common method that was noted in the text is a lactic acid fermentation, which can either be homo or hetero in terms of fermentation. To be hetero would mean the byproduct is not simply lactic acid, it would be lactic, ethanol, and acetic compounds coming out of that. So the carboxyl remnants from the pyruvate get transformed into acetaldehyde. And in phase 2, the electron transfer causes ethanol and NADH plus to be made. Now, why would that be made? Why is that important? It's not exactly, the same as full-on ATP. Now, the text noted that the main purpose of the fermentation cycle is that there would be enough NAD plus for glycolysis to occur. So fermentation is relying on glycolysis for those short blasts of 1 or 2 ATP molecules instead of the final burst that cellular respiration would provide in that last phase of the respiration process, which would be the oxidative phosphorylation. So thank you all so much for coming along with me on this. I know it's a little bit confusing, but I was really thankful for the opportunity to learn more about what isn't so often explained in the younger school years. I hope you enjoyed. Thank you.